Okay, hello everyone, and welcome to our webinar today. This is Why Industrial Data Management Matters More Than Ever, brought to you by Cognite, AI for Industry. I'm really excited about the content and the speakers today, and just wanted to kick off with a few housekeeping items. First, we will be recording this webinar, so if you want to share this with your team or if you want to revisit any of the points, you'll get an email in the next couple days with the recording, and you can watch it on demand. The other thing here is we love getting questions, and we hope that this is interesting to disperse some questions and some engagement. So find the Q&A box. We've reserved a little bit of time at the end to go through some of the questions, and anything that we don't address, we'll address in person via email. So our content today is really well organized. We're going to kick off with a little bit of framing and then share a little bit of the landscape of industrial data management vendors from Verdantix. There's some great perspective here on the overall landscape. We'll also spend some time with Novachem and their really interesting digital transformation journey, some great insights for other industrials that will be on the call. And then lastly, we'll tie this together a little bit with how industrial data management fits into AI. So we've got a great panel lined up today, and I'd love to introduce them next. So first, Joe, do you mind giving a quick introduction?
Thanks, Gabe. So yes, I'm Joe Lemming. I'm a senior analyst at Verdantix. We're an independent research and advisory firm based in London. We have offices in the US as well. My background is mechanical engineering. I spent a few years in manufacturing, and in my 3 years at Verdantix so far, I've looked at industrial data management, of course, and many of the applications that you build on top of that, including AI analytics and generative AI.
All right, and then Ahmed, do you mind introducing yourself as well?
Yeah, no, certainly. Hello, everyone. I am Ahmed Musa, a digital transformation leader overseeing digital transformation in manufacturing at Nova Chemicals, based in Calgary, Alberta, Canada. I focus on leveraging AI and data-driven insights to enhance plant operation and reliability. I'm very excited today to discuss how digital innovation is reshaping really the industrial maintenance and how organization can capitalize on these advancements to optimize operation. Thanks for everyone.
Great. And then last but not least, Knut.
Hi, everyone. I'm Knut Vidvei. I'm Senior Vice President of Product Management at Cognite. I'm responsible for our product management functions, which includes our roadmaps and the overall direction of our products. Great to be here. So, one of the reasons, the main reasons why we want to gather us today is to talk about how the new state of industry is. And what we're observing and what we're hearing is that all of these operational teams out there in the industry are expecting to do more, but with less. There's a rising operational demand. There's a pressure to maintain production levels and efficiency standards while you're optimizing cost and dealing with workforce shortages and even tighter budgets. So there's a pressure on all of us. And there's also a growing amount of data. That this has been true for a while, but even now, after all of these years, we still see that there's limited insights into this vastly growing amount of data. And while this is happening, we're still being asked to ensure the same safety and compliance levels. Regulations are still growing, and they're present, and they are different across the world. And there's also then this overall global transition in workforce and globalization. So this comes down to the bottom line that we need scalable solutions. There's demand for scalable digital solutions without having this added level of complexity, even though complexity is inherent in what we do. So taking us over, what does this then mean for us? Excuse me. This means that the organizations must find effective and sustainable ways to adopt new ways of working and use this technology to address all of these constraints. So industrial organizations must streamline their workflows, enhance the safety, and reduce downtime in this complex environment we're talking about. So that takes us over then to the three more ways to approach this. So how do you harvest the power of AI in this complex world? How do you do it safely, and how do you do it at scale? This growing interest of enabling industrial AI, you need to consider how AI can become an operational enabler and not an operational hazard, and bring more efficiency and agility to your operations. So in order to get started with this, you need to have data, and it needs to be connected and trusted. We call this contextualization, but the AI must be able to work both with real-time data and high-quality data, and they need to be contextualized in order to deliver outcomes that is reliable in industry. And as we go into a more complex world, you still need to be able to scale, but you don't need to, you cannot have this linear scaling where you have to do equal amount of works for every new use case you do, or every new plant or site that you roll out to. So you need scalability without the complexity. So deploying industrial AI and agents, they should enhance you, they should enable you, should make you better, faster, and stronger, and not disrupt your existing workflows. So it needs to be a part of your decision-making process and enhance it, and not disrupt it. And lastly, we're not going to get away from this: security, governance, a robust and open and secure data architecture. That is the foundation for your AI. So the AI should not introduce new threats to your security and governance, or data leakage, or IP leakage. It should be part of a trusted foundation. So you can adopt it without having to compromise on operational safety or your internal operational standards. So with this introduction, I'm happy to pass the microphone over to Joe Lamming, who's going to talk us through some of the agenda points that is why we're gathered here today.
Thanks, Knut. So as you can see in the agenda that we'll be looking at the Verdantix section of this webinar is going to be, first of all, top trends in the IDM market, then introducing some of the vendors that we see within industrial data management, and then we'll finish the section with why industrial data management is the hardest part of deploying those sort of automations, the AI agents. So let's get into that. So beginning really, we better have a definition for industrial data management. Obviously, sometimes you would call it industrial data fabric, industrial data ops, but really what we decide to go with for all of the way that we're communicating this topic and all of our reports and advisory is industrial data management. And we define this as you can read here, software facilitating that professional approach to managing data, specifically in the asset-heavy industries, improving data quality and facilitating collaboration between the SMEs and the data scientists, or like constructing data pipelines for tracking, verifying the data origins, governance, from the moment of acquisition through its usage in AI, analytics, whatever it is, and eventually to archive or deletion. Next slide, please. So I did say we're going to look at some data. This is a sort of data cut of one of our recent global corporate surveys. So we spoke to 304 industrial transformation, operational excellence leaders all around the world, obviously focusing on asset-heavy industries. You can see at the bottom there things like oil and gas, discrete manufacturing, process manufacturing, utilities. And the question was, which of the following maintenance approaches do you currently follow? So as you can see, the way these numbers add up here, there is a lot of overlap because it's asking maybe you only focus on your critical assets, maybe it's on some of your assets, general assets, but you can see right at the top in terms of what is most followed, as you'd expect, corrective maintenance. If it's broke, you fix it. That really makes sense. Similar with planned maintenance, you have on a schedule, you have something, usually you might as well go check something, replace a bearing, replace a gasket, just on a schedule, fairly straightforward. People have been doing this forever. You go down to, let's say, condition-based maintenance. Again, this is a little bit more where you need to have those sensors, some of that data acquisition. Predictive maintenance, that's again where you need your sensor analytics in there. Preventative maintenance, kind of similar there, but then least popular, as you can see right at the bottom of this chart, is reliability-centered maintenance, where you've got your sensor analytics alongside your domain knowledge. And yeah, you can see it's just over half of the respondents that we spoke to are using this in at least one of their critical assets, which I thought was quite interesting. So again, right at the top there, corrective maintenance as you'd expect, and then far less prevalent, but still, some vendors using it, some of the assets for that reliability-centered maintenance. Next slide, please. So this question here, as you can see, industrial decision makers, they see budget constraints, data quality, trust, and low availability of vendor solutions as significant barriers to AI project success. And the question asked is all about the barriers, specifically AI analytics projects in this particular question. And you can see as we ranked it, as the way people have put down whether it's very significant, insignificant, or they're unsure. At the very top, lack of budget. But really, once we start talking about data management, it's that poor quality or incomplete data that is obviously a barrier to the AI analytics projects. And similarly, it's the lack of trust in the insights generated. People are very much aware of how, you feed a machine learning model, you train a machine learning model on a bunch of data. Some of that data is badly labeled. If it contains a lot of noise in there, really what you can end up with is insights that just don't really align with what the actual domain experts know well, and therefore they will not use the tool. So really, obviously, a significant barrier here. Next slide, please. So onto some market size and forecast data. So this was a report that I believe was published towards the end of 2024. And you can see the growth rate as we go from 2023 up to 2029 for industrial data management. The growth rate is significant. It's around 20%. 20.4% goes to specifically industrial data analytics, and then 18% growth, 19% growth goes to the industrial data ops there. But certainly once you break it down on spending, so around $1.8 billion expected spending in 2024 versus $633 million spent on industrial data ops. Certainly the biggest spending, as we see it as part of this market size and forecast, is going towards the analytics. Obviously, and kind of the way that people often think about this is the analytics is the stuff that really people can more easily measure the return on investment. But you cannot get, as we saw in the previous slide, we cannot see that you can't trust the insights from these analytics without having your industrial data ops or industrial data management solution as the foundation to those analytics. Next slide, please. So this was from another survey, yet again, this time looking more not just across industrial decision makers, but also some of the enterprise decision makers, this time 252 respondents. And this really asked just about what people expect to use, what they're currently using, what they're going to be using in 2026. And many of these categories, they're quite broad. There's some overlap there. But really, as you would probably expect, most deployed as of when this was done, around towards the end of 2024, most deployed as chatbots. People are using some of their enterprise licenses to something from Microsoft, something from Claude. These are obviously going to be very popular. People might even be using some of the consumer-facing versions of this, obviously because LLMs can be very, very useful. And then generative AI, maybe, obviously chatbots being a subset of that today. People be using image generation, some of the kind of multimodal models to help with things. But really, obviously, people are using chatbots. They are using generative AI already within their enterprises, within their organizations. Now, looking forward into the rest of this year, it's interesting that a lot more people expect to be using natural language search a lot more, not just the keyword search, not just the thing you can type into, Windows File Explorer or something like that, or Finder in Mac OS, but something that can actually do semantic search, being able to search the content of your documents, regardless of where they are, as long as they're indexed somewhere. People are interested in being able to actually tap into their index and to surface technical documentation, unstructured data, semantic similarity with some of that data. And that is something that people are expecting to be deploying more in 2025. There are many commercial solutions, many capabilities of existing enterprise software that are allowing this more and more, obviously, because the technology is just getting really, really good. And similarly for machine learning, people are interested in being able to train their own models, build their own models, not just being able to write Python, but being able to use some of the low-code tools to actually start training these domain-specific models, whether it's time series models, image categorization models, something that is very specific to whatever use case they need, where they know that they have lots of data, why not train a machine learning model to help improve that process, do some categorization. And then looking into 2026, we have the retrieval augmented generation. It's a much harder thing to do well, especially when we start talking about the variety of industrial and enterprise data that someone might be wanting to retrieve from and to generate responses using some sort of LLM. That is something that people are realizing, again, once it goes to trust. There's a big trust barrier there. People are seeing these kind of chatbot or RAG systems sometimes work, sometimes not work. And that is why people are deploying it. People are seeing some successes, but it requires quite a strong foundation to be able to do that well. So therefore, people are expecting, as you can see in the data here, 2026. And similarly with this autonomous AI agents, a lot of the AI agent builders that some commercial solutions are offering, building around not just the search engines, building around your RAG system, but building on that data platform is something that people expect to be using more and more in 2026. Next slide, please. Now, this one, again, from that same survey I just mentioned, of the 252 industrial and enterprise respondents. At the very top, as you'd expect, in 2024, where do you see the most AI-related projects? It's going to be in sales, marketing, customer service. Not really super relevant to industrial firms, but what is the operations and maintenance. Again, almost 50%. They already saw in 2024 projects that were using some AI tools, and similar with supply chain as well. And now looking into this year, remainder of this year, as you'd expect, sales, marketing, customer service right at the top there, operations and maintenance, but also EHS. EHS is one where some of these respondents that we spoke to see actually being used a lot more within their organization in 2025. Next slide, please. So now let's start talking a bit about the drivers and the barriers. So really pilot project successes and increased internal expertise, they're pushing against the intrinsic complexity of these AI projects and of course the implementation cost that goes along with that. So let's begin with the drivers there. You can see 87% of people said that successful AI pilot projects really, that obviously helps with adoption. You can say, look, it worked in this use case. These are the things that we had to do. This is what we had to do to the data. This is how we presented it to the actual users of that data. Let's scale this up. Obviously, yeah, vast majority of people say that can be a massive driver there. Similarly, increased internal AI expertise, that really makes sense. They're really going to have people that understand this complex technology and be able to communicate it to the business users, communicate it to the people that are holding the budget, controlling the budget there. Obviously, massive driver there. And similarly, success stories from your peers in the industry. Almost 50% people there say that is a massive driver. Does it work without data models? Does it work without kind of data? Okay, maybe it'll work for us as well, if it works with your peers. And then onto the barriers, like I said, the complexity. We're talking about large language models, large action models, multimodal models, retrieval augmented generation, vector search, graph databases, graph RAG, all these different technical terminologies that some of them have been around a long time. Some of them have been around for a few months. This stuff is evolving very quickly, and therefore the complexity is high. And of course, you have the technology consultants, the costs that go along with that is a massive barrier there. And then finally, you can see 61% say that it's the cost of the AI software, including just the token usage to these various LLM endpoints. And maybe if you're trying to host it yourself, just the gigantic costs of H100 clusters. You can see a lot of people feel that is a huge barrier to the adoption of AI technologies. Next slide, please. So like I said we'd introduce the IDM vendor landscape. So a lot of what I've been talking about here, this is all sort of wrapped up in this report that was published back in January. It is the Green Quadrant on Industrial Data Management Solutions. I recommend everyone take a look at this report because it goes really deep into the topic. And in that report, we'll be talking about the industrial data management solution provider landscape. So this diagram is obviously a lot going on here, a lot of vendors on here, but really what it's representing, you can see at the top of the outer perimeter is OT data, that's time series, events, alarms, inspections, EAM, CMMS, control systems, IoT data, streaming data, whatever it is. That is your OT data, operational technology, really the core industrial data. You go along the bottom left there on the outer perimeter, it is IT IT data. So that's your data warehouse, your data lake, your ERP, your HR system, CRM, financial data, all of that. And then the bottom right is the engineering and technology data. It is technical documentation, piping instrumentation diagrams, 3D CAD, GIS, all of the kind of very unstructured, quite sort of specific kind of data to specific kinds of engineering, design, operations software. And the vendors, as you go around here, the vendors that are able to kind of tap into all three of these types of data, the OT, the IT, the ET, are the ones that really are able to have these quite flexible data models, these data models that can represent the same piece of data in various different contexts. If it could be used by a business user to do supply chain optimization versus a process safety coordinator versus a process engineer. That same piece of data might be useful across all of them. Therefore, you do need to have some data models that are able to represent that data in a way that is best aligned to whatever use case they have, whether it's aggregating the data in a certain way, whether it's tagging the data in a certain way, mapping those tags across different domains. This is really something where some of the vendors, as you can see in the middle here, for example, Cognite, you can see at the center of this diagram, we believe are able to merge the OT, the IT, and the ET. Next slide, please. So I mentioned a little bit to do on the previous slide to do with maybe the industrial data hub providers, maybe it's the industrial data ops platform providers, and then the industrial data ops ontology providers or industrial knowledge graph providers. And the first two approaches here, the data hub and the data ops platform, on the left with the data hub, really we can think of this as being the most simple data management and analytics use case. It's where you have your data sources, your industrial control systems, PLCs, whatever they are, streaming IoT devices, time series data sources that might go through a broker, going into historian to really kind of give you that time series data. And then you can sort of configure that together, flow configuration through something like Node-RED, for example. There's a very popular sort of for these really pilot project is something called the Ming stacks, MQTT, InfluxDB for your time series, Node-RED for this flow orchestration, and then Grafana for some of the visualization of that. That is a common approach for these pilot projects, for these quite simple sort of analytics for industrial processes, that sort of thing. As you start to want to address a little bit more of your industrial data, not just the IT, but also the OT, you need to go towards what we describe as a data ops platform, standardizing the hierarchy, contextualizing through perhaps a unified namespace, and also being able to write back some of those control points, the bi-directional control from your ICS, IoT time series, EAM, ERP, relational database management systems, connecting to it, brokering it, contextualizing it within the UNS, and then visualizing, analyzing, and control at the very top there. Now, on to approach 3 on the next slide. We will see what we believe is the most complex approach, but also the most capable approach. And this is where you're able to not just tap into your OT and IT data, but everything that a large sort of multinational, really complex organization might want to tap into. So industrial data, but also some of the P&IDs, the technical documentation, 3D files, images, video, GIS, ERP, all the way through to your CRM, your supply chain management system, even markets data. Being able to represent that kind of data within a single industrial ontology and industrial knowledge graph really allows, again, modeling and making it discoverable, allows people, data scientists, process engineers, business users to build the visualizations, the really deep analysis, and of course the automations. And when I say automations, that could also include AI agents, all built on top of this industrial data ops ontology. Next slide, please. So this here looks at the green quadrant. I mentioned this was the report. So these are some of the scoring capabilities and momentum criteria that were used as part of the analysis to provide the visualization that we'll go to just in a second. So some of the capabilities we looked at were, did the vendor offer the ability to tap into direct industrial data? Do they tap into the PLCs? Maybe it's in the indirect industrial data, so that they could tap into time series historians, OSI Pi, other things like that, data modeling, the data storage, cybersecurity, unstructured data utilization, discoverability, contextualization, and platform APIs, and then the data interoperability as well. These are some of the capabilities that were assessed as part of this project, where we had a 111-point questionnaire, we had hours-long demos, lots of conversations with customers, conversations with peers. It was a really, really interesting long project towards the end of 2024. And similarly with the momentum, we'd be looking at things like brand preference, vision and strategy, product strategy, innovation process, fundings, M&A, customers, revenue growth, all of that sort of thing. And on the next slide, we will see this is the green quadrant. Again, this was published in January of this year. Participating vendors, the ones that took part in all of the sort of lengthy demos and questionnaires and assessments and that sort of thing, ABB, Aviva, Cognite, Cybus, Hexagon, High Limits Automation, Symphony AI. And yeah, these are some of the vendors, and you can see the placement here. So as you can see, Cognite being in the leaders quadrant. Next slide, please. So let's finish with why IDM is the hardest part of deploying AI agents. So I mentioned LLMs, talked about some of the capabilities, some of the complexities, some of the cost involved in them. And here is a good example. You can't just feed an LLM. It's an example from GPT-4o. It's a very popular model used in a lot of enterprise industrial software. You give it some unstructured data to do with some inspection. It's got some information in there. Maybe you tell it to turn that into a particular structure. Let's say, oh, put it into a labeled property graph. You can see, yes, it does a job at this. But if you go to the next slide, basically what this is trying to describe here is that when you have this industrial knowledge graph, when you try and build the industrial knowledge graph, and you have some of the complexities of it, you need a very consistent data model. And to be able to sort of resolve entities, to be able to resolve data models across different domains, you need to be able to feed the LLM a very specific data model depending on what that domain is, because you can have a sparsely connected small knowledge graph that can work and be useful for some domains, but really what you want to be getting to is towards the right-hand side, where when you can directly model the concepts, you can help the AI systems retrieve the direct answer by being able to feed it more context. So a densely connected large knowledge graph is where you're able to tap into all of those different data sources, extract the semantic relationships between them, encode those semantic relationships in a way that is somewhat standardized, or at least standardized enough to have all those relationships discoverable in a way that really makes sense to the human user and also to the autonomous AI agent user. Next slide, please. So just to wrap up here, we'll talk about some of the approaches, really. So the approaches 1 and 2. So this is the very simple one, whether it's the Ming stack or whether it's maybe the data ops platform offering, where you're really kind of focusing on the unified namespace. Really, it's about being able to tap into metadata indexing, native utilization of that metadata, assembling the disparate data into payloads, all about contextualization, maybe having a good graphical user interface to allow the business users, the process engineers, the kind of domain experts, shop floor workers to be able to interface with that data and add to it, contextualize it further, having out-of-the-box OT and IT data sources, and then, of course, end-user reconfigurability as needs change, and then the ability to robustly scale with cybersecurity. Now, on the final slide here, we'll talk about approach number 3. This is the most complex one, really the industrial data ops ontology, the industrial knowledge graph, with that full IT, OT, ET orchestration. So what you need there is really the out-of-the-box industrial engineering and IT system connectors, the data modeling, not just across time series and events, but also the unstructured data, built-in modern visualizations and AI analytics tools, model training tools, and then the deeply configurable data transform and automation, and mapping these all across the different domains and use cases. And then often the way that we see these, it's really cloud oriented. If you're going to be running across lots of different facilities, you want to have your data centralized, you want to be able to scale up compute, storage, depending on what your needs are at any particular moment. Really, these are often cloud oriented offerings for global deployment. I think with that, I will hand over to Ahmed.
No, thanks, Joe. Absolutely. So here at Nova Chemicals, about a couple of years ago, we started a journey to be really the first choice of our customers. And when we looked at that new mission or new goal, we looked about the strategies that we're gonna really be the first choice of our customers. One of them was, hey, that we will need a digital transformation across many value streams, several value streams within Nova Chemicals, and including our operation. And then we embarked on that journey to look at how we can be the most reliable supplier of polyethylene with the digital transformation as a vehicle to achieve that. Next, please. As any typical petrochemical industry, we operate in highly complex environment. We have variety of equipments. We operate crackers and so ethylene crackers and polyethylene plant. So we have high temperature operation. We have numerous thousands of equipments, either from instruments or rotating equipment, static equipment. And when we try to do the analysis on them, we figure out, hey, well, of course, we have unplanned downtime that causes production losses. And also we figure out there's a lot of insufficient resource allocation because we have a lot of corrective maintenance activities. And then we were thinking, okay, how are we going to go about changing that direction and position Nova in a better place through digitalization? So, of course, was to move from time-based or reactive-based into more proactive-based maintenance reliability. With that, we created something we call the end-to-end reliability maintenance. The next, please. In that reliability, excuse me, in that end-to-end reliability maintenance, the thought was, hey, can I immensely really shift my maintenance approach to reliability into more proactive and data-driven, where I can really start predicting when the failure is going to happen and really track it along their journey from the prediction of the failure all the way to physical fix and closing out the job. I will talk more to it in a couple of slides from now. Yeah, next, please. The challenge we have when we have that vision about the end-to-end reliability and maintenance, we say, oh, guess what? We have all those data, but they're all siloed and they're all scattered. And often when you want to do maintenance, really you want to pull in on your historical work orders, your process data, your design and engineering information. And we say, well, it would be very hard really to just plug and play solution and unless you bring them all together. The other one also, what we found is that when we started looking at our workflow, we had a lot of mundane tasks that people doing in terms of either extracting data or really just doing their day-to-day job. And then we say, okay, well, we need a platform that can really bring it all together, creating a one layer that we can really build solutions on top of it. Next, please. And that's when we went last year to really scout and explore that data layer that we need that can contextualize all those operation for data and engineering information, maintenance-related information, and everything else that we want to bring in to enable a use case to deliver that value. And of course, we elected Cognite to be our partner into this journey. Next, please. So really when I was talking about the end-to-end reliability and maintenance, as I say, so imagine is the machine speaks to you, telling you, hey, like I'll be failing in 3 or 6 months on and tell you specifically what it is. Is it a bearing? Is it a gasket? And then an SME look at it and say, yes, I trust the data, I can confirm. But just imagine the way we're doing it now is really that create automatically an AI agent, create notification, an AI agent, create the work order, another AI agent looking at the schedule and really stack it along with the other PMs that are coming through that funnel to really schedule where will be the appropriate time. We're looking at even about if you don't have the parts, hey, can the machine automatically setting an order to your preferred supplier to order the parts for you, factoring on the leading time, all the way to the execution, pushing that work package to your tech to do the physical work and closing it. A few things this year we focusing on is, as you can see here, is highly focused on predictive maintenance and automation of the workflow. As well as we want to do is, hey, look, when there's a failure happening or we're predicting a failure, how can I digging into it quickly as a reliability engineer or reliability practitioner, where I can pull everything into one space and start doing my own equipment troubleshooting, or when the equipment failed, how can I do a quick RCA on it, uh, easily by looking at the PNID, historical IP2020, or system one vibration, whatever data you need. That this should be all in one spot for that equipment. And those are the things now currently we are piloting. Can you go next? And so, as I say, it's all coming together. And can you go next? Don't mind. And we building it now. We're piloting this end-to-end concept in one of our plant here in the east of Canada. We are in this journey about, this is our 5th month in it, and we already start seeing the results are coming through our use cases and value that they're delivering to our plant. What's next for us is now once the pilot completed and we harden the solutions, is how quickly we can really move the learnings from this plant and scale to the rest. And for example, if we're doing predictive maintenance on charged gas compressor or cracked gas compressor in the FAA plant, how easy I can really scale to the other 3 or 4 plants I have. And that's really the scaling we are going through. So scaling all those solutions. The same thing with the maintenance workflow. We trial it and we piloted it in one of our assets. How can now I really do it in an enterprise to move the OMC, the operation maintenance coordinator, the planners, the scheduler, the tech maintenance tech into the new automated workflow part of that. And of course, the other thing what we're doing is that integrating an AI driven insight into the day-to-day job. So imagine if you are a planner and then an AI agent telling you, hey, like you received now new 2-3 packages and this is how being authorized. I created them. They sit at 70 or 60% quality, and now you're just coming in and just close that gap with some of the manual work. But at least the AI agent gave you that boost that created the first pass of your work package. Yes, we are very excited for this journey and being partnered with Cognite. I can't wait to scale to the rest of the assets. And to you, Knut.
Thank you very much. Thank you, Ahmed. This has been a fantastic example of how to approach this data operations and AI in the industry. So how do you then go about building the foundation to get started? I think that's the question that we probably get the most, is that how do we get into the position that Nova has done and really get our feet off the ground without this turning into a unmanageable large thing that we can't really know where to get started on. So you cannot skip the first step. And that's basically building the data foundation, as both for your operational needs and as specifically in the age of AI. You need to connect and organize your data into a knowledge graph and break it out of the silos and make this data available, make it available for your people, make it available for your processes, and then make this accessible also for AI agents. This is the crucial first steps. And you also then need to have the right tools, the right methods, and be able to consume this data and these insights efficiently. And one of the key points here is that doesn't necessarily have to take that long time. This can be done in weeks, not in years. We'll get back to that point later. But if we take the next slide, this builds then the foundation for the next step. The next step is then to start very quickly use this in operational use cases. Some of them can be out of the box and others can be more tailored enterprise solutions, but basically start with an opinionated way to get into your operational use cases. Understand the value that you're driving for. This immediate value you want to get, not as a digitalization process, but as a company, as an operational goals. What kind of levers do you want to move? And then operationalize those use cases very quickly. So solve them and then build it on a foundation so you can solve it at scale. So if it works for one plant, you can scale it to all the others. If it works for one use case, you can scale that use case to other use cases as well. And that finally then takes us into the future, the North Star that we all should have at the end, because should we know what you are aiming at. And that is this modern world where things are more autonomous, more data-driven, and also complemented by AI agents across your enterprise. And then you need the ability to orchestrate, you need the ability to see this at a global scale, and then orchestrate this, and then also give it to the AI agents so they can help you. So orchestrate those agents as well. Next slide. So with this, as Joe mentioned, you've seen during Joe's presentation, we're honored to be recognized by Verdantix as the leader in the green quadrant of industrial data management solutions in 2025. And we were humbled to be providing this leading data ops and AI for enterprise scale and encompass industrial data management solutions. So thank you very much for the collaboration there. And it's a nice recognition of the very focused work we've been doing to position us both as a data management, but mainly because we are 100% industrial. Next slide. So in that report, we'd like to highlight some of the things that sets Cognite apart. Our key value proposition is this open ecosystem where we unlock the hidden insights for even better operational outcomes. To do that, we build it on top of a very powerful data modeling framework that is tailored to industry. That means that it understands industrial data. It can do it at the high volumes and scale that is required, and it does it across all the different types of data. You would get both out of your IT systems, your engineering system, and your operational OT systems. Those data really come to life with advanced data contextualization, break down industrial silos, enhance your decision-making, and that contextualizes in your data, but also connects that to real-time data for even more industrial use cases. Another thing where we have a differentiation is our approach to AI for industry. I believe that Cognite is the fastest way for you to realize tangible value with AI in industry. And through that, we believe in orchestrating and with AI agents, and make those agents as part of you, complementing you into the operational workflows that you already have. Then we also have utilizing the unstructured data. It's not just the tabular tables and the easy data to get to. It's the ones that comes from PNIDs, as Joe said, that one comes from engineering diagrams, from 3D models, from documents with a lot of hidden information in them that we can extract and pull into the knowledge graph and make that more available. So you don't spend time looking for data, you spend time solving problems. And that lives on foundational principle of an open architecture and a high speed and a fast-paced product and development. So the open architecture is basically there that the future work of industry is autonomous, it is data-driven, and it is complemented by AI. And that requires a strategy for you and an architecture for you to be in an open ecosystem, because you need all these different systems to talk together. It cannot be done with these lockdown ecosystems of the past. In this modern day and age, you need an open ecosystem. So then comes back to, again, how do you get started? On the next slide, we end with this, what we call the Cognite Data Fusion Quick Start. That is a proven and prescriptive way of just getting started in weeks. You can generate value within the first 90 days. We have native connectors to over 80 industrial data sources. We still haven't seen an industrial system that we couldn't connect to and extract the data from. It provides that unified access across all of your data sources for collaboration, for your first use cases. it's purpose built for industry, and it's purpose built now for the future of AI. So with that, we have closed out the presentation part of this, and Gabe will take it back to Q&A.
All right, thanks, Knut. And thank you to all of the speakers today. I think that was really interesting, just highlighting if you're trying to do AI, you got to solve the data management problem. And I think we laid a really good foundation for that. I've been seeing questions come in from around the horn, so I think we'll go right into Q&A next. And again, if you have a question or you want something addressed, we'd love to answer it here in the next little bit. So I've got a question here around, how long does that data foundation step typically take? Maybe a question for Knut, and then also we'd kind of love to hear maybe from Ahmed as well, like from user, how long did that data foundation step take for y'all?
So getting started, I think it's really important not to boil the ocean. You should have a big plan and as a vision of where you're going, but you should start with something like the quick start. That independent if you go with Cognite or not, getting the first few data sources connected, pulling it in, contextualizing them, getting it into the knowledge graph so that you can start working on the data and see the results almost immediately. So within weeks, we have a package, and it varies a little bit with different companies, but you should be able to get that started within the first maybe 6 weeks. And with a lot of value driven along the way, and you should really start seeing the impact of that within the first 90 days. But I'll also pass it over to Ahmed for his real world experience.
Yeah, no, absolutely. There's you don't want to do everything. It's supposed to be like use case driven. So what data really needed to unlock the value for your organization? You scope this one out. So I'll give you an example of one of our asset is like a 100,000 tag work order in the SAP, about like 3,000 PDNI. It took us about really 2 months to bring everything in, contextualize it. We call it first pass. And of course, within your organization, you're going to set up a data governance, and you want to say, okay, what's the level of your contextualization, and are you good with, let's say, 60%, 80%, 90%? What's the level of comfort? And of course, the level of comfort ties into the use cases. That's the most critical use cases. You want to make sure that you have the right data and the cleanest and so on and so forth. The one that really you don't pay attention to accuracy can really temper this one down. So I agree with you, Knut, you don't need to boil the ocean. It's need to be really focused on the use case and the value need driven. And then it's really a matter of, I would say, the weeks, max to a couple of months. Okay.
No, it makes a lot of sense. We've got another question here around cybersecurity. And the question is, what about cybersecurity or potential data breach? How is Cognite tackling this issue? So I think, again, another question for Knut here, but then I'd also love to hear maybe from Joe, your perspective on whether one of the three approaches has a better, solves the problem better or not. So go ahead and hand it over to Knut.
Yeah, thank you. It's an extremely important question, and it's one we work with every single day and with our cybersecurity team. The most important thing is to understand your security levels and the settings you want to have. Being in the modern cloud, being on a very updated, that is being updated and patched and secured every single day, over time is in reality more safer. With Cognite, we approach this by having very strict internal audits and cybersecurity standards. We also have external audits. So we have SOC 2 compliance, we have our ISO security and standards compliance and certificates. So we follow very strict development processes. We also have continuous monitoring of those to make sure that everything is fresh. And then we use all of the recommended standards when you look for. So we also have companies come in and do independent penetration tests, do reports and follow-ups on those. And we work with your cybersecurity teams. So one of the first things that we can do is that we also very early on engage with the cybersecurity teams of our potential customers and we work with them continuously as well. All in all, this drives a very high cybersecurity standard because we know that this operational data is extremely important to you, and they're very important to us as well.
No, but thanks. And then Joe, just clarifying, I know in those three approaches, is there one that is better suited for modern cybersecurity challenges, or do you have a perspective there?
I can certainly say for approach one, again, this is the one that is best described as the Ming stack, so MQTT, InfluxDB, Node-RED, and Grafana. Certainly a lot of Node.js, a lot of JavaScript, a lot of TypeScript in there, a lot of dependencies, and certainly I've heard some horror stories of when that system is deployed far and wide, including connected to the internet, running on the internet, lots of ports open. So no, approach one works very well for simple use cases, kind of whether it's sort of air-gapped systems. Really, once you start wanting to deploy more than that, sort of multi-site, maybe you do have some open ports you want to be able to send up to one of the cloud services, or maybe working fully on the cloud. Yeah, approaches 2 and approaches 3, the ontology ones, the cloud-focused vendors, as Knut said. Yeah, you kind of have to be doing your stuff properly. Otherwise, it'll just be a cascading nightmare because, yeah, a lot of these software tools are able to write back. They're able to write back to the control systems, recommended control points, and yeah, you need to be able to do that OT/IT convergence in a proper belt and braces way.
Can I make a point there as well on AI, Gabe?
Absolutely.
So I think we've all seen a vast amount of different solutions where they say, like, for example, choose our solutions, upload all of your documents into this data bucket. We'll put a large language model on top of it, and now you can chat with your documents. It's one of the early and very interesting use cases. If you do that too simply without thinking about access control, cybersecurity is a lot about access control as well. You basically have just lost all of the access control. So anyone who has access then to that LLM can then go and get access to all of the contents in those documents. So when you start to pilot with generative AI, consider using a proper data operations platform where the access to those files are still kept in. So if you have them in that knowledge graph and you retain the access control, if you then apply generative AI or chatbots on top of that, they will then still respect the access control that you have. So you will have cybersecurity and access control baked in. That's one of the things that's, I think, is the advantages with Atlas AI, is that you keep the access control, you keep the cybersecurity aspects, because the AI agents are not allowed to access these things. It's only you as a user and your access that is driving what the AI has access to. So you're not, I think that's a word of caution for people to think about before choosing a solution.
Yeah, no, great insights there. Another question here is if the timeline data or other kind of data as text recommendations, for example, can be used together by AI at this moment with Cognite tools. Can you maybe expand a little bit on the AI capabilities, Knut?
Well, let me make sure that I understand the question. The timeline date and other kind of data, text recommendation, for example, can be used together by AI at this moment with coding tools. So I'll interpret the question in a way that can you combine different types of data, like time series data or text-based data coming out of documents and all that? And we have definitely yes. This is one of the big insights, because the agent framework that we have different tools. Some of these tools that the agent can use is reading time and analyzing time series data. Some of them is reading and understanding documents. Some of them is understanding work orders and SAP data. Some of them is just querying the knowledge graph. So one example we have is someone's looking for the fault, or they have an issue with a leakage, and it goes in and finds the fault tree based on an ISO standard. So it reads a spec document. Then it goes into another specification document to find out what could the failure modes be. So that combining that with text data, then goes in, can check work orders, has any work been done on this lately? And then it goes in and checks the time series and see actually if the temperature has been breached over the last 3 months. And it tells you, yes, it has. And it can then even come back and then give you a prescriptive. So it can read different types of data. So it got the temperature range it should be in from one document, and then it checked it against the time series and say that the relevant sensors have been exceeding it. And yes, it had, then it said, then you should go and change the oil and do these kind of procedures. So it also can be prescriptive, looking back. So this multimodal approach to industrial data is actually where you start seeing it. If you just take one at a time, you can have insights. But when you allow an agent to orchestrate across multiple types of data, that's when you get the huge benefits. We've seen up to 97% time saved, for example, in the root cause analysis, because it could do this multimodal approach to data.
Gotcha. I think there's a small follow-up here for Ahmed. Ahmed, can you maybe share a little bit more? You talked about your AI approach a little bit, but are you all planning to use some of this technology in your operations?
Well, of course, the AI technology is really what is when you drive the insight. So we are using those technology for the predictive maintenance, just like what Knut mentioned, to really detecting those anomalies and specifically, contrast this one with failure analysis to understand, hey, what's really causing that. AI agent for automation of the work packages, AI agent to optimize scheduling for the maintenance. Yeah, absolutely.
Nice. And maybe a follow-up here for you, Ahmed. I know there's questions on, how are operations teams involved in the deployment of digital technologies, and I'd love to hear your perspective there on how that teamwork worked between digital and between operations to kind of get user acceptance, and maybe could you share a little bit more about that?
Yeah, no, certainly. So the management of change is digital transformation is a change. So management of change is really a key component into really driving the adoption of the new technologies. But when you go all the way to the shop floor and you start really talking to the end users and about their pain point, and you try to develop solutions that are user-centric, of course they will have the business lens on them. You have no idea how much the adoption is shooting because they see it, this is my solution, this is my co-creation, this is my idea now materialized. So when we went to scout where we're going to do the pilot across all the units, we selected the unit when we saw a lot of pull. People they say, hey, like this is really going to help my job day to day. This is going to give me some white time to really think and about continuous improvement instead of just crunching same job day in day out. So management of change, work with the end users, and of course there's to be a business lens. It has to drive value to the organizations. Eventually you're in a business organization, and of course the support of the leadership about, hey, the vision and the strategy that we are after.
Now, those are some great insights. And maybe zooming out a little bit to the market as well. Joe, have you seen characteristics of companies that are able to move a little bit faster at digital and adopt AI? Like, is there anything that stands out for why they're able to move faster than other organizations, why we're taking a more aggressive approach?
Yeah, I mean, I'll probably go back to one of the earlier survey points. I won't make you go back there, but it was interesting. It was very polarized. I think it was talking about some of the most significant barriers, and one of them said it totally wasn't a barrier at all, having sort of expertise within your organization, kind of people that are champions of using that kind of technology, and another saying, yeah, it was a huge barrier. And it's usually because you don't need very many people in the organization that are really pushing this, know how to communicate this within the organization, that really understand the technology, understand where the technology is going. So usually you just need a fairly small team of people within your organization that get this. That'll make a massive difference in being able to convince many of their colleagues, including the budget holders, to actually go ahead and go through the pain of deploying something really complex like an industrial data ops ontology, an industrial knowledge graph, and all of the analytics and automations and AI agents on top of that.
That makes a lot of sense there. I think we're right about on time here. If there are other questions, please follow up with us directly. You can submit questions at contact@cognite.com, and we would be happy to follow up with you directly. I just wanted to thank everybody one last time for the presentations today. Again, I learned something every time I talk to y'all. So thanks again. Thanks everyone for the Q&A. We'll go ahead and wrap today, and thanks again, and stay tuned for the next webinar.